Joining us now is Catherine Oertel and Annette Richards. Thanks so much for being here. We appreciate it. You guys are speaking on the art and science of organ pipe metal. And before we dive into all that, you know, MRS is an organization that's founded on interdisciplinary research, and the two of you are a perfect example of that. A chemist collaborating with a music professor specializing in 18th century music. Can you talk about how the two of you got together?
Yes, well, I met Catherine at Cornell when she was a graduate student there in chemistry and came to study the organ with me. So we had many conversations in the organ loft during organ lessons about her research. And I was at that point involved in a project to do with historic organs in collaboration with partners in Sweden. And we came up with the idea that Catherine might find interesting the kind of research they were doing that was scientific and related to her own research in chemistry.
Yeah, so I was studying solid state chemistry as a graduate student, and I learned through Annette about a group in Sweden that involved material scientists and corrosion scientists who studied organ pipe materials, and I sort of thought, I really need to be part of this. And so I got a postdoctoral fellowship that let me spend some time with them in Sweden and then continue the work in the US. And so we've stayed in touch all this time, even though it's actually been quite a few years now since that got started, yeah.
Sure. And your discussion here at this spring meeting, the art and science of organ pipe metal, obviously just the two of you, but it goes much more beyond that, right? With so many different people in this area?
Right, so the group in Sweden has been instrumental in beginning this research and bringing different people together. So as I said, there are corrosion scientists there, organ builders there, musicologists there, who are important in all of this.
Got it. So what specific properties and materials in these organs kind of make them the king of all musical instruments?
Well, in a non-technical sense,
yes.
The thing about the organ is that it involves so many different types of technologies, different types of skills to make them. Organs, you know, as objects, they are made of. They require architects, organ builders, painters, sculptors. They're extraordinarily interdisciplinary as musical instruments. And then within the intimate environment of the sounding material of the organ, you have wood, metal of many different types, leather, glue. It's a very complex materials environment. The pipe metal itself is extremely important for the way the instrument sounds and the ways in which the instrument is built. And this is what has been the focus of Catherine's research.
Yeah, it must be extremely interesting.
Yeah, it's extremely interesting. One thing that I find fascinating too is how early scientists had an empirical understanding of how these materials behaved, and we're now able to understand it from the atomic level with chemistry and with material science, and so it's interesting to see those two types of experiences come together. So lead tin alloys are used to make organ pipes and have been for a long time, and their particular materials properties are important for how they react to sound. And then my research has had to do with how those metals interact with their environment and suffer from corrosion over time.
Can I just add that what people don't often realize is how old the organ is. I mean, it's a very ancient instrument, and many old instruments still survive in Europe. Fantastic, very large organs that already in the 14th and 15th century had the technologies that they have today. So they were at the absolute forefront of technological advance already way back then.
Sure.
So you had to be a great metallurgist to make a big organ pipe that would stand up.
Certainly. Annette, what is it like to play one of these organs?
It's an extraordinary thrill. It's an extraordinary thing, partly because they are incredible musical vehicles.
Sure.
And also because they tend to be very much part of the building that they're in. So you're playing the whole building when you do it. But also, these old organs, one has really a strong sense of a very long tradition of players and listeners and kind of communities of scientists and artists essentially coming together to create them. So you're very much in the center of a very long historical tradition, and it's an absolute thrill in terms of the sound.
And we have a sample of what this organ sounds like.
Yes.
What are we going to be listening to
We're going
quickly?
to hear the great Dutch organist Jaap van Oort playing a piece of Bach on the organ instrument Bavo Haarlem from 1735.
All right, let's take a listen. Okay, thank you so much for providing that sample. Gives us a little sense of what your talk will be on. Now, in addition to restoring these, what's the ongoing preservation effort for these instruments, these unbelievable instruments?
Well, one of the things that we've learned through the corrosion research has been that the acids that are quite corrosive toward lead tin alloys are actually not acids that come from greater environmental problems, but they're very local to the organ itself. So they're acids that are released from the wood of the organ case as it ages. So some of the strategies that can be used to reduce that problem include things like pretty low-tech solutions, including better filtration of the air system. Also things like coating the wood with nanoparticles that act as sinks for the acids as they're released. And also there have been sensing systems that have been developed that live in the organ case and can alert curators if the acid levels get too high.
So you stay ahead of it. Yeah, sure.
Right.
Get it. Annette, Catherine, thank you so much. We'll enjoy your discussion here at the spring meeting.
Thank
Thanks
you
so
very
much for being here.